This first video of this unit is going to be on reviewing radicals and how to work with them. So we're going to first start with just simplifying the radicals. And we're going to simplify them by making a factor tree. When we do a factor tree, we look for matched pairs because perfect squares make matched pairs. Matched pairs make perfect squares. So if I'm breaking down 320, I'm looking for two different numbers that are going to multiply to give me 320. So 10 and 32. I can break down 10 into 2 and 5. 32 can be 2 and 16. 8 and 2. 4 and 2. 2 and 2. When you are looking for pairs, we're going to look for all of the last numbers, so all the leaves of the trees. We're not going to look at 10 because 10 broke down to 2 and 5. We're going to look for pairs. So here's a pair of 2s, so that 2 goes to the outside. Here's another pair of 2, so that 2 goes to the outside. Here's another pair of 2, so that 2 goes to the outside. Anything that was not matched up, which would be this 5 right here, is going to stay on the inside of the radical. Any number that you pull out is going to be multiplied together. Any number left over on the inside is going to be multiplied together. So on the outside, we've got 2 times 2 is 4, times 2 is going to give us 8 root 5. So when I break down that radical, 320, it becomes 8 root 5. When we are multiplying radicals, it's all about location, location, location. We multiply numbers that are in the same location together. So 3 and 6 are both outside the radical, so I multiply them. 3 times 6 is 18, and it stays outside. 8 and 20 are inside the radical, so they're going to stay inside. 8 times 20 is 160. Then, just what we did, we're going to simplify this radical. We're going to break it down using a factor tree. So we've got 8 and 20, 4 and 2, 2 and 2, 2 and 10, 2 and 5. We're going to look for all of the different groups, pairs of 2s, and then we have a 2 left over and a 5 left over. We want to be careful here. We already had an 18 on the outside of the radical. We don't want to forget about that. So the 18 was already there. We're bringing this first 2 out, so we multiply by 2. We're bringing another group of 2s out. On the inside, we've got a 2 and a 5 left over. So 18 times 2 is 36. 36 times 2 is going to give us 72 on the outside. 2 times 5 is going to give us 10 on the inside of the radical. When we go to adding radicals, we have to add like terms. In order to be considered a like term, it has to have the same root and the same number inside that root. So we've got 27. We break that down with our factor tree, 9 and 3. 3 and 3. We've got a group of 3s with a 3 left over. The group of 3s goes to the outside. The 3 left over on the inside. 25 is 5 and 5. That's a perfect square. If there's nothing that's left unmatched, then there's no radical. So that's just minus 5. We've got 48, which is 4 and 12, and 4 and 3. I could go ahead and keep breaking down 4 and 2 and 2, but I'm looking for matched pairs. Since I have a pair of 4s, I can go ahead and bring that group to the outside. There was already that 2 there, so that's 2 times 4 root 3. So that's 3 root 3 minus 5 plus 8 root 3. Now these are like terms because they both have the root 3. So 3 plus 8 is going to give us 11 root 3. We're going to put the whole number, the integer, out front. So negative 5 plus 11 root 3 is our final answer. All right, now to the tough one. The hardest operation to do with radicals is dividing radicals because there's so many different ways we can divide radicals. One, we can't have a fraction underneath the radical. So the first thing I'm going to do here is I'm going to look to see, can I simplify 12 over 49? No. So I'm going to break that into 2 pieces, the numerator, which is the square root of 12, and the denominator, which is the square root of 49. I'm going to break each of those down with the factor tree. So 12 is 4 and 3, 2 and 2, a group of 2s with a 3 left over. So this becomes 2 root 3. We look at 49. 49 is a perfect square. It's 7 and 7. There's nothing left over. So I divide that by 7. When I go to see if something can simplify, I look at location, outside numbers together. The 3 is inside the radical, so I can't reduce that to anything. I look at the 2 and 7. That does not simplify, so my answer is 2 root 3 all over 7. We're going to do the opposite in number 2. I've got 7 root 20 over root 2. It's all about location, location, location. Inside numbers together, outside numbers together. Well, 20 and 2 are both inside the radical, so I can go ahead and put those underneath one radical. Then I can simplify. 20 divided by 2 is 10, so that becomes 7 root 10. I try to break down 10, but that's 2 and 5. There's no matched pairs. Therefore, my final answer is going to be 7 root 10. Now comes the worst case scenario is I have a radical, but nothing's simplifying. In our final answer, we can never have a radical in the bottom of the fraction, the denominator. So what we have to do is rationalize. To rationalize, you multiply by whatever root you have down there. So since I have root 5, to rationalize, I multiply the top and bottom by root 5. 3 is outside the radical, 5 is inside, so those are going to stay separate as 3 root 5. We have a 2. 5 times 5 is going to be the square root of 25. The square root of 25, that's a perfect square. 25 is just 5 and 5. So that becomes 3 root 5 all over 2 times 5. And we did that. The whole reason why we multiplied by root 5 was to make a matched pair so that I no longer had a radical. So we've got 3 root 5 all over 10. Now you may want to think that you can simplify this 5 and 10, but you can't because 5 is inside the radical and 10 is outside the radical. I would have to look at the 3 and 10, and those do not reduce. One thing that you want to make note of is any radical times itself cancels the radical out. So root 2 times root 2 is the square root of 4, which is just 2. Root 3 times root 3 is the square root of 9, which is just 3. You're creating that matched pair. So we know that root 4 times root 4 is just 4. Root 10 times root 10 is 10. Any number times itself in the radical, that radical is going to cancel out to give you just that number. All right, that is it for today's video.